Hello everyone, welcome to DC Minds. In this video, we are going to learn about a smart pointer called auto pointer, which was introduced in C++3 itself. So now let's see how we can create this smart pointer using AutoPTR. Okay, so in this case, first of all, to create a smart pointer using this AutoPTR, we have to include a header file called memory.h or just memory. Okay, so here what we are doing, we are creating a pointer using this AutoPTR, and this PTR will be pointing to the memory that is allocated at runtime using this new keyword. Okay, or operator. Okay, so now to create a smart pointer, first we'll give this auto ptr and then the data type, whatever the type of, like whether you can give float, character, any data type you want, and the name of the pointer and the memory using this new. And then using this dereferencing, we are assigning some value to the memory that this ptr is pointing to. So in this case, we don't have to delete this ptr explicitly, this pointer explicitly, because since it is a smart pointer, it will get deleted automatically when it goes out of the scope. When this function scope ends and this ptr will goes out of this its scope, then what will happen, this ptr will get deleted automatically. Okay, so basically the memory pointed by this ptr will get deleted automatically since it is a smart pointer. Okay, so now let's see another example of auto ptr. So in this example here also, we are creating a pointer that is a smart pointer using this auto ptr, and now we are assigning the value to the memory to which this ptr is pointing to. So here we are using get. So get function is used to get the address of the memory location that this ptr is pointing to. Okay, so and used by dereferencing this, we are assigning the value. So first we'll get the address of the memory to which this ptr is pointing, and then we are dereferencing and then assigning the value. So now at this line of code, this it will give the output of the memory location, that is address of the memory location to which this ptr is pointing to. Now at this line, what we are doing, we are creating another pt pointer called ptr2, and then we are making this ptr to point to this ptr which we are created over here. So in this case, what will happen now, this ptr2 will become the owner of the memory that this ptr was pointing to. So now if you run this program at this line of code, the output will be null, that is 000. So this is because auto pointer cannot be shared. Basically the memory can be owned by only one pointer. Okay, so this is how we'll say there is a only one owner of the underlying pointer or memory. Okay, so this is the behavior of auto pointer, that only one owner is allowed. Okay, so and also we know that it can be moved to a new owner. So here what is happening, this ptr2 is becoming the new owner. So when you say ptr2 dot get, at this time you will get the same address over here. So because now earlier this ptr was pointing to the memory to which the this basically the address here, and then now this ptr2 is pointing because we have moved the ownership of this ptr to this ptr2. Okay, so auto pointer cannot be shared and only one owner is allowed to hold the ownership. Okay, now let's see some of the function of auto pointer. Okay, so at this line of code, it will give you output which is the value of the memory location. Okay, and the final output will be like this. And here we'll see the release function of this auto ptr. So release is used to release the memory that is been holded by this PTR, and it will assign to null basically. So here what we are doing, we are creating a smart pointer using this auto PTR, and the smart pointer is nothing but this PTR. So, and we are trying to get the address of the memory to which this PTR is pointing to. So you will get some address like this, and this can be different in your case, but you will get some address. And now we are using this release function. So at this line of code, what will happen, this PTR will release the memory. Basically the memory pointed by this PTR will get released, and it will point to null. So what we are doing, we are assigning that memory to this PTR2. So now PTR2 will be pointing to the memory location to which this PTR was pointing to. And now if you add this line of code, the output will be this. So what will happen, now PTR is pointing to null because PTR dot release will release the memory. Okay, and now it will make this PTR to point to null, and this PTR2 will be pointing to the that memory location. So now we'll get the same address that we got at this line of code. Okay, so now PTR is pointing to null, and this PTR2 is pointing to that memory location, and now we are deleting it explicitly. So this is the use of release function. So basically it allows us to release the memory that is being held by this pointer, that is auto pointer, and that is called a smart pointer. Okay, now let's see another function of auto pointer, that is called reset. So reset is used for two purpose. So let's see the first purpose. So reset is used to release the memory. Basically whenever you want to release the memory, and when it goes out of the scope, it will get automatically deleted. But if you want to delete before it goes out of the scope, you can use reset. So in this case we are creating a pointer, and this will be pointing to some memory location, and we are trying to get the address of that memory location. So you will get output like this. So it will, this is the address of that memory location. And then what we are doing, we are saying ptr dot reset. So at this time what will happen, the memory to which this ptr was pointing to, it will get deleted. And when you say ptr dot get, now you will get as null because this reset function will delete the memory. Okay, so the output will be like this. And now let's see another use case. So here another use case is this. So first we are creating a memory, and we are trying to get the address of that memory location. So you will get something, some address like this, and that can be different in your case. Okay, and now what we are doing is we are making this pointer which was pointing to the memory whose address was this, to a different memory location. So at this line of code what will happen, the memory that was pointed by this ptr earlier will get deleted, and now this ptr will be made to point to newly allocated memory. So when you say ptr dot get now at this line of code, the output will be different because here the address was different, and now you say if different address. This is because now we are making this ptr point to different memory location. Okay, so overall output will be this. Okay, so now let's see some of the disadvantage of auto ptr. So the limitation of auto pointers are as below. So auto pointer cannot share the memory. So at the time only one owner is allowed to hold the ownership of the memory that is pointed by auto pointer, and we cannot create array using auto pointer. Okay, so and it is deprecated in C++ 11. This is because in C++11 we have a concept of unique pointer which allow us to create array. Okay, so in next video we will learn about unique pointer and how you can create a smart pointer with the help of unique pointer, and what are the various functionality and its advantage and disadvantage. Okay, so this is all about auto pointer. Thanks for watching. If you like this video, please subscribe to my channel and hit the like button, and check out my other video to learn other concept.